today we're going to be talking about the sound waves, and we also are going to talk about how we hear and what sound has to do with us. So let's go ahead and get into the assignment. So first things first, compression is high molecular density and high air pressure. Refraction is a lower density and pressure. So when you're doing compression, it's going in, and when you're going out, it's refraction. Sound waves and vibrations of air molecules are parallel to direction of the wave motion. Well, as you remember, we have the sine curve, which is this one. So sound waves are always also longitudinal. You have your crest, which is your compression, which is your high. You have your trough, which is your refraction, and that's your low sound. Characteristics of sound waves: you have what's called frequency. Frequency is the number of cycles per unit over a period of time. Audible is what we actually hear. Humans are usually 20 to 20,000 hertz, makes it audible. And then we have sound waves. Frequency is less than 20 hertz. Infrasonic waves is greater than 20,000 ultrasonic waves. So we have what's called pitch frequency on an audible sound wave, determines how high or low we perceive sound to be. Speed of sound depends on a medium, which is a solid, liquid, or gas, also along with temperature. Sound waves propagate from three dimensions. You have where you have the source, you have the wave, ray, you have the wavefront, and then you have lambda. Sine curve is showing you. Doppler effect is which is the pitch abundant siren. So if you had a siren that was coming up behind you, it would sound closer and louder than when it leaves you. And that is having to do with the frequency shift. And that was all section 1. Section 2 is talking about sound, intensity, and resonance. Intensity is the change in E divided by the change in time over area, which is P divided by area. Intensity of a spherical wave. You have the intensity equals the power divided by 4 pi r squared, which is the distance from the source squared. So it gave you a question or a problem in the book. And the problem sample in the book was talking about what is the intensity of a sound wave produced by a trumpet that has a 3.2 meter when the power of the trumpet is 0.20 W. Assume that the sound wave is spherical. So what we're going to be doing there is we're going to be doing our calculation. And our calculation is we're going to do alpha y inner, because it is a fraction. We're going to do our 0.25, and then we're going to do a open bracket 4, and then we're going to do our pi, close bracket, open bracket, and that is 5.0, close bracket, and that has to be squared. And that's going to give us 7.95 times 10 to the negative 4, which I'll run it up to 8.0 times 10 to the negative 4. So then let's look at the practice problems that are underneath. Calculate the intensity of a sound wave with electric guitar amplifies a distance of 5 meters. What is the power output equal to the following values? If it's 0.25 watts, you're going to take your 0.25, so you're going to do your alpha y inner. You're going to do 0.25 down. You're going to do your 4, and then you're going to do your pi. Open bracket, 5.0, close bracket, squared, inner, and I got 7.95, which I rounded it to 8. The next one says 50.50 watts. You're doing the same thing as you did here, except you're changing it to 50, and you should get 1.6 times 10 to the third, negative 3 watts. C has to do with 2.0 watts, and you're just doing the same math there, and it's 8.81 times 10 to the negative 3 watts. Number 2, What is the maximum level of loudness of a power outage of 75-piece orchestra rating a sound of 70 watts? What is the intensity of these sound waves of the listeners who are 0.25 meters away from the orchestra? So we're going to take our 70 watts, so we're doing alpha Y enter. We're going to do our 70 over, and we're going to do our 4 pi, and then we're going to do 25, and we're going to square it, and that gives us 0.008. So I want to go ahead and change it, and that will be fine. Or you can change it to scientific since it's such a small number. And that's where I got the 8.81 times 10 to the negative 3. So either number is right. So intensity of frequency determines what sound is audible. You have a softest frequency, which is 1000 hertz, and the intensity of 1.0 times 10 to the negative 12 watts per meter squared. Threshold of hearing is the loudest curve. What you can actually listen to that will hurt your ears. Threshold of hearing is the lowest curve. It's what you can actually hear. The threshold of pain is the loudest noise in 1.0 watts per meter square. A relative intensity is measured in decibels. Decibels are dimensionless units that describe the ratio of the two entities of sound. The threshold of hearing is commonly used as a reference to intensity. Also, then it talks about force, vibration, and resonance. Like a guitar string, when you are using it, it uses somatic vibrations. Vibrations at a natural frequency produces resonance. And resonance is a phenomenon that occurs when the frequency of a force applies to a system matches the natural frequency of the vibration of the system. And then the last thing it talks about is you hearing. There's 3 sections of the ear. You have the outer, the middle, and the inner. Inside of there, if you're going to talk about hearing something, it goes from the outer down your ear canal to the eardrum, which that is right there, which connects to your hammer, anvil, and stirrup. And then it goes and transmits to the nerve inside your brain. And that's how you hear. Now, I'm sorry it was late today. I had several meetings this morning. I had some meetings with the district, some with Dr. Pridgeon today. And so I was running a little late. I did put this up late. I will try to do better tomorrow by putting this up here. I just want to make sure you understand these links to YouTube will always be here for you, so that if you need to come back and reference them, maybe you're taking a college class and you're taking a physics class and you need to know about sound waves, this will be perfect for you. I hope that you're having a blessed day. You only have till Friday and then you're done. And then makeup work, you need to do at least by next Thursday. Grades need to be turned in for the seniors on the 15th. I want to let you know I miss you, and I'm hoping I get to see you soon.